Okay, so this is as far as we got in the last one. So we're just going to finish this off now. We can use the particle model, and you remember the particle model is what we learned about back in the chemistry topic about how solids, liquids, and gases can be understood in terms of the particles. So we can use the particle model to help us understand the density of different physical states. We know that in a solid, the particles are packed closely together, whereas in a gas, they are spaced far apart. So if we were to draw the particles in a solid and in a gas, if you could just quickly just draw what those would look like. So you can pause the video while you remind yourself what they look like. So you should now have diagrams that look roughly like this. Okay, and you'll remember that in a solid they're packed together in this close arrangement, whereas in a gas they're far apart, and in fact in a gas they're much further apart than this. That's one of the problems with the particle model, is that we can't show it here how far apart they really are. But what we can see is that if I make my solid a little bit bigger actually, we can see that in the same volume we've got many more particles of solid than we have of gas. Okay, so even though the volume is the same, so let's say here the volume equals 1 meter cubed, and this volume equals 1 meter cubed. All right, here we could say our mass is, well, let's say, for example, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Our mass is 15. And here our mass is 3. I'm not going to give it any units because this is just a sort of a simple calculation to illustrate the difference in density. So now we can say that the density is 15 divided by 1, which is 15. And over here, the density would be 3 divided by 1, which is 3. Now, I'm not saying that the density of a solid is 5 times the density of a gas. What I'm saying is that you can see how from the way that particles are arranged in solids and in gases, we can understand that the density for a solid is much larger than the density of a gas. Okay, so from this we can see that in the same volume of solid and gas, there are more particles in the solid and fewer particles in the gas in the same volume. Therefore, the density of a solid is high and the density of a gas is low. The density of a solid and liquid are much more similar, although there will be some small differences depending on what type of substance it is. Okay, so difference in solid and gas, very large. Difference in solid and liquid, not so much. Okay, so obviously then a gas still has a lower density than a liquid. All right. So the final thing that we need to talk about is the second of our concepts for today, temperature. All right. So temperature, as you will know, is a measure of how hot or cold something is. It is measured using a piece of equipment called a thermometer. If you're not sure how to spell thermometer, you need to test yourself on spelling thermometer. How hot or cold something is depends on how much energy the particles have. So you'll remember that the definition of temperature is to do with the amount of kinetic energy, how fast the particles are moving. In a hot object, the particles move faster. When you heat a pan of water on a cooker, energy is transferred from the chemical energy store of the fuel into the kinetic energy of the particles. So if you think about a pan of water, okay, and that's full of these liquid particles. They are closely they're close together, like in a solid, but they're not in the same regular arrangement that you would have in a solid. Okay, and we might have here, let's say we've got a piece of wood, and that's burning. All right, so in our piece of wood, we have energy in our chemical energy store. Okay, and as the energy transfers, these particles start to move faster. okay, and the energy is transferred into the kinetic energy store of the particles. So the particles will start to move quicker, okay? And that's what we mean by temperature. So we can say that high temperature means more energy in kinetic energy store of particles, which means that the particles move faster. All right. So you could think, from now on, when you get cold in winter, maybe it's because the particles in your body aren't moving fast enough. Although that's probably not the best way to describe it to somebody. So, although the temperature tells us about the energy of the particles, it is different from energy itself. Okay, so this is a common mistake that people make, is they get this idea of temperature and energy a little bit mixed up, and they start to think it means the same thing. Okay, and it doesn't. All right, and I'm going to give you an example. You'll do more of this next year, like I keep saying, but I'm going to give you an example that will illustrate to you why temperature and energy are not the same thing. Okay, so the energy of an object tells us the total amount of energy in all of the moving particles, but the temperature tells us the average energy of the particles. So, how can I illustrate this to you? Well, let's imagine that you have a swimming pool. Okay, this is a swimming pool. Let's say it's an Olympic-sized swimming pool. So an Olympic-sized swimming pool is 50 meters. It's going to have a depth of 2 meters. So this swimming pool is huge. Okay, and we're going to put into the swimming pool a thermometer. All right, and the temperature of the swimming pool is going to come back as a nice, let's say, 20 degrees. Okay, now somebody comes along and they take a glass and they scoop out a glass of water from the swimming pool. Okay, so they take a scoop of a glass of water and they put it into a glass. Okay, and they measure the temperature of that glass of water. What will the temperature of that glass of water be? Hopefully, you said 20 degrees C. Okay, because obviously if I take a glass of water out of this swimming pool here at 20 degrees C, then the water I've taken out will be 20 degrees C. So you can see that they have the same temperature. However, if I was to ask you which has more energy, the swimming pool or the glass of water, hopefully you would tell me that the swimming pool has more energy because the swimming pool has more particles. Okay, so let's just summarize what we've said here. So we've said same temperature, and because they have the same temperature, they have the same average energy. The important word there being average. Okay, so we can think of that as being that the particles move at the same average speed. Okay. However, swimming pool has more particles, and you'll remember up here I said that the energy of an object tells us the total energy of all the particles. So the swimming pool has more particles, therefore the swimming pool has more total energy. Okay, so one final thing. Let's say that I want to increase the energy of this by 1 degree C. And I want to increase the energy of this by 1 degree C. Okay, so my challenge to you is, all right, you need to increase the temperature of the swimming pool by 1 degree or increase the temperature of the cup by 1 degree. Which one would you rather do? Okay, now hopefully you would choose to increase the cup by 1 degree C. It's much, much easier to do that than it is to do that. Even though you're increasing them by the same amount, because there's more particles here, you need to give much, much more energy in order to do the same temperature change. Okay, so this is quite easy. This is very, very difficult and require a lot of energy. Okay, and hopefully that helps you understand this difference between temperature and energy. So, what you need to do now is answer these 6 questions. Okay, so first of all, to get you warmed up, I've got some unit conversions, then I've got some density calculations, then I've got some mass calculations and some volume calculations. You will need to be careful because I specify here grams per centimetre cubed, but I'm giving you mass in kilograms for some of them. So read the question very carefully. Those are all quite straightforward. Some of these you see here, I've got grams, but the density is in grams. Here I've got kilograms, but the density is in grams, so you need to think carefully about here. You need to change the mass into grams first. Okay, and then these 2 questions are about what I've just said about energy and temperature. So it takes 4 kilojoules of energy. There's a spelling mistake here, so this should be of energy to heat a litre of water by 1 degree C. How much energy is needed to heat the litre of water by 15 degrees C? So that's fairly straightforward, isn't it? Okay, if 1 degree C is 4 kilojoules, 15 degrees C is going to be 4 times that. All right, so I think these questions, I've tried to make them as straightforward as possible, so have a go at those as well. All right, and that's it for this week.